equation. Let's start with the definition of linear equations in one variable. So first of all, before understanding what are the linear equations in one variable, let's first try to understand what are linear equations. A linear equation is an algebraic equation in which each term is either a constant or the product of a constant and the first power of a variable. An example would be 2x plus 9 is equal to 3. In this case, we see x is the variable here, 2 is the coefficient for the variable x, 9 and 3 are the constants, and 2x plus 9 on the whole makes an expression. So a variable is a quantity that may change within the context of a mathematical problem. Typically, we use a single alphabet to represent a variable. So what we're trying to say here is that 3 and 9 are going to remain constant wherever you take them. But x is something that in this expression itself could take different values. So if you take x is equal to 1, you could take x is equal to 2. You could take any value of x. It's a different thing that equation may not hold true for all different values of x. But x is something that we're taking as a variable, something that could change its value as we change the context of the problem. An equation is a statement of equality of two algebraic expressions. So in this case, we say 2x plus 9 is the expression on the left hand side and 3 is an expression on the right hand side. And when two expressions on the left hand and right hand are separated by an equal to sign, that forms an equation. So let's see the representation of the linear equations. Some of the examples of linear equation are 5x is equal to 9, 2x plus 3y equal to 8, 14x plus 2y plus 3z is equal to 9. And these are just some of the examples. There could be many more. You could take any example with just one or more variables and then you can form an equation like that. Now, are they all linear equations in one variable? No. Linear equation with the number of variable as 1 is said to be the linear equation in one variable. Now if you see these three examples above, we know that 5x is equal to 9 is a linear equation in one variable because it's just one variable, that is x. But in the second equation we see x and y as two variables. So that's not a linear equation in one variable, that's a linear equation in two variables. And if we see the third example, we have three variables x, y and z. So it's linear equation in three variables here. If the left hand side and right hand side has only one variable and the others are all constants, then the equation becomes linear equation in one variable. Now the important thing here to understand is that the linear equation in one variable only specifies that the variable to be used has to be 1, but that same variable could be used either only on the left hand side or only on the left hand side, or it could actually be used both on the left hand side and the right hand side. So it will still stay a linear equation in one variable. An example is 2x plus 9 is equal to 3x plus 5. Now here we see that the number of variable is just one, which is x, but it is being used both on the left hand side and the right hand side, and it still is a linear equation in one variable. So if we talk about what are inverse operations? In mathematics, we have two pairs of inverse operations, and we all know addition and subtraction is one pair and multiplication and division is the second pair of inverse operation. Now in equations, we use the inverse operations to shift something from one side of an equation to the other. And why we say something here is it could be a number, it could be a variable, it could be a term. So we are using, when we shift something from one side of the equation to the other side, that means the left hand side to the right hand side or from right hand side to the left hand side, then we use the inverse operations. So when it's moved to the other side of the equation, it gets the sign of the inverse operation. Say for example, we take ax is equal to b, and when we take a to the right hand side, x becomes equal to b by a. So a, which was actually getting multiplied by x, now b gets divided by a, because when a is moving from left hand side to right hand side, instead of multiplication it takes the division sign along with it. Now what is transposition rule? So now we just talked about the inverse operations. Now when we apply that inverse operation in case of addition and subtraction, that is called transposition. When a number or variable in an equation is connected by the plus or minus sign, it could be taken to the other side of the equal to sign by prefixing the contrary sign to the term. If it's having a plus sign on the left hand side, then if you want to take to the right hand side, it'll get a negative sign, and vice versa. So if x plus a is equal to b, then if we want to take a to the right hand side, x becomes equal to b minus a, and this is called transposition rule. Now why do we actually want to do this transposition is because we want to isolate the variable x here. We want, if we have to find out the value of x or the possible values of x, in this case, in case of linear equation, it will be only one value actually. So if we want to find out the value of x, we need to isolate x. So that is why we would want to use these transposition rules. And the second thing that needs to be done for isolating the variable is exchanging sides when we want to actually keep the variable on the left hand side. Now exchanging sides actually does not require any change in the sign, and the reason is that when we are exchanging side, we are just moving whatever is there on the left hand side to the right hand side and whatever is there on the right hand side to the left hand side. So effectively, if we had to change the sign, every single term would get a different sign, would get a changed sign. So it is equivalent to not changing signs at all. And what is exchanging sides? If we are to say a is equal to x plus b, we could also say x plus b is equal to a. And that is when we call it exchanging sides. This is where we don't need to change any signs. X is equal to a minus b is the change in the, it does not require any change in the signs. Now let's see how do we solve linear equations. Solving linear equation means finding the value of the variable which will satisfy the equation. So say for example, in the previous slide, we had taken an example where we are saying x is equal to a minus b. Now that is when we know what is a, but when we know what is b, we can actually find out the value of the variable x, and that is called solving the linear equation. So for solving the linear equations in one variable, what we do as a first thing is, as an important thing is, we take variable only on the one side, which could be either the left hand side or right hand side, although the preference is always to keep the variable on the left hand side. So if we see this equation of the type 3x plus 8 is equal to 5, or put it just by changing the sides, we can say 5 is equal to 3x plus 8. Now variable, if you see the variable is on one side, we agree, but the constant terms are present on both the sides. So what we want to do is, we want to take only the variable on one side, and we want to take all the constant terms on the other side. To do that, what we do is we make it 3x is equal to 5 minus 8, which means 3x is equal to minus 3, and hence is equal to x is equal to minus 1. So this is how we solve the equation 3x plus 8 is equal to 5 to find out the value of x. So let's now try to solve the equation where the variable is present on both sides of the equation. So let's take an example where the equation is 5x plus 9 is equal to 3x minus 8. Now all the terms with the variable are brought on one side of the equality sign, and the constant terms are taken to the other side using the transposition rule. So what we do is, we take the original equation 5x plus 9 equal to 3x minus 8, and then we move 3x to the left hand side and we take 9 to the right hand side, making it 5x minus 3x is equal to minus 8 minus 9. That makes it 2x is equal to minus 17, and x is equal to minus 17 by 2. Equation. Let's now try to understand what is the application of linear equations. Why do we do them? Why do we actually, take the variables and what is the and create the equations and then solve the values of the variable? What is the real need of it? So now a number of practical life problems can only be solved by forming a linear equation and then finding a solution for the same. If we were not to form the linear equation, then there would be a hit and trial method, which would be a much longer approach. So let's try to see what do we need to find out. Now, some examples of the linear equation problems would be, first is the distance, speed, time kind of problems, where either the distance is given to us and time is given to us. We need to find out what is the speed of the vehicle, or any other two things could also be given. We given the speed and we given how much time did the vehicle take to travel from one point to another, how much is the distance between those two places. So those are the kind of things that we need to solve using linear equations. Then we have the kind of problems where part of the job is done and the rate of the completion of the job is given to you, the time is given to you, and then you need to find out how much more time is required or how many more people are required to do the remaining part of the job. Then there are mixture problems of the nature that if you have 5% water in 95% milk, and that kind of a solution is there, and then you have another solution of different with different ratios, you want to mix them, what is the ratio that you'll finally get? Then you have number problems where you need to find out one number based on certain statement as to this number is this many times greater than the other number and things like that, and you have to find out the number. Then there are money problems where you need to find out how much money would be needed if you were to buy certain amount of things and certain number of things to be taken. And then you have area perimeter problems. Obviously, the length and breadth of the rectangle is given to you, or the radius of a circle is given to you, and you need to find out its circumference. So those kind of things are require linear. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.